In this example, we have a product of an exponential function and a trigonometric function. Exponential x multiplied by the cosine of x. So once again, we're going to use our rule, the integration by parts. So if we look at this, which one are we going to pick for u? So if I go back there, what will we pick for u? So u is equal to what? So we follow a rule. Case number one, is one of the functions a log function? No, it's not. So we move to rule number two. If there's no log function but a power of x, but we don't have a power of x, so we move to number three. If there's no log function or power of x, then exponential x is taken as u. So that's determined our exponential x, and dv is whatever's left. Cosine x dx. So we differentiate the u to get the u dx is exponential x, and that implies that du is equal to exponential x dx. On this side, we integrate dv is equal to cosine x dx. That implies that v is equal to the integral of cosine x is sine x. So now we have our formula, u dv. I'm going to rewrite that, differentiate correctly between u and v. U dv is equal to u times v minus the integral of v du. And if we fill in our values here, u is exponential x, dv is cosine x dx is equal to u times v. Well, u is exponential x, v is sine x, minus the integral of sine x, and then we have du is exponential x dx. So this is my u, that's my v, that's my v, and that's my du. So you can see here that we're going to have to go around here again. This is equation 1 here. Sorry, the whole thing is equation 1, but this is, we're going to have to go through the process again where we apply the rule of integration. And this time we're getting the integral of exponential x times the sine of x dx. So once again, we set u equal to exponential x. Therefore, du dx is equal to exponential x implies that du is exponential x dx. Now at the start, I should have specified that we're going to let this equal to I. So then if I come back over here, that's my du, and on this side we let dv equal to everything else, sine of x dx. We get the integral of both sides, and that gives us v is equal to minus cosine x. So we're going to fill those values into our integration rule, integration by parts rule. So u dv is equal to uv minus v du. So the integral of exponential x sine x dx is equal to u, which is exponential x, multiplied by v, so I'll put it in brackets because there's a negative sign there, minus cosine x, minus times the integral of minus cosine x times exponential x dx. So if I tidy this up, I bring the minus to the start. So it's minus exponential x cosine x. We have a minus and a minus here. Minus and a minus here. Minus multiplied by minus gives me a plus. And here we have the integral. I just swap the order of these around. Exponential x dx. So I just swap the order of these around. So if we then come here, you can see that that's what we started with. And at the start, you let that equal to I. So that gives us minus exponential x cosine x. And if you notice up here at the start, we allowed this term here equal to I. Up here, this integral is equal to the big letter I. So I just substitute that in here. And this here is equation 2. So if we repeat equation 1 then, up above, I'll just take it here and I'll take it down below. In fact, what I'm able to do, no, I'm not able to copy it. So what, I can duplicate it, yeah. So if I come here, I don't need to rewrite it. I can just duplicate everything here. Duplicate it, and I can take it down. So I don't have to bother rewriting it. And this is the one that we're looking for. And that's the one that we have. And then the idea is we'll substitute in our I here. So exponential x cosine x dx is equal to big I is equal to exponential x sine x minus, and here we have number 2, which goes in here. So I substitute this into here. I'll show it in the green here. I substitute 2 into 1, so everything in that green box comes down into here, minus exponential x cosine x plus I. And therefore we have an equation here with I on both sides. So we just do simple algebra. So this implies that I is equal to exponential x sine x. Here we have a minus times a minus giving us a plus, exponential x plus cosine x, and here we have minus times I. So of course, and we have a constant of integration. So of course that means we bring across the I, so we have I plus I now is exponential x, and I can factor that out here, so it's sine x here plus cosine x here plus a constant of integration. And that's 2I, of course, when you bring it across. So that implies that I, this of course is equal to, if I shorten it here, that's equal to 2I, which is equal to that. And that implies that I is exponential x over 2 times the sine of x plus the cosine of x plus a constant of integration. So that is the completed solution, where I in that case is the integral of what we were looking at the start. So we can say that the integral of exponential x cosine x dx, which is I, is equal to exponential x over 2 times sine x plus cosine x plus a constant of integration to finish it off correctly.